Hi guys, let's go ahead and wrap up chapter 5, lesson 2. All right, so the first main heading that we have is future space flight. And then our second heading that we're going to look at here is going to be space technology. Okay, so go ahead and highlight space technology in green and future space flight in purple. All right, so let's go over to our outline, our science notebook. And so we are going to highlight human space flight, and I think that they call it future space flight in our reading essentials. That's totally okay. And then down here for space technology. All right, and then that actually wraps up the chapter. So we're going to go ahead and put our line right here. Wraps up the lesson, I should say, and then that's as far as we're going to go today. All right, you ready? All right, so let's take a look at what we need to do with this first section, what we need to be concentrating on. So we're going to contrast the differences among 3 programs that involved putting people in space. So we're going to look at the Apollo Project Apollo, the STS, and the ISS. All right? Okay, so let's go into our reading essential. Sending humans into space was a major goal of the early space program. However, scientists worried that radiation from the sun and weightlessness in space might hurt people's health. So they first sent dogs, monkeys, and chimpanzees. So we're going to go ahead and highlight that. That's pretty interesting. All right. They first sent dogs, monkeys, and chimpanzees. In 1961, the first human, an astronaut from the former Soviet Union, was launched into Earth's orbit. Not much later, the first American astronaut orbited Earth. The Apollo Project. In 1961, U.S. President John F. Kennedy challenged the American people to place a person on the moon by the end of the decade. The result was Project Apollo. So it looks like a vocab word. So Project Apollo, a series of space missions designed to send people to the moon. In 1969, Neil Armstrong and Buzz Aldrin, Apollo 11 astronauts, were the first people to walk on the moon. So Apollo 1, okay, started out with Apollo 1. So there were several missions, and Apollo 11 was the one that got these 2 men to the moon. Okay, so space transportation systems. Early spacecraft and the rockets used to launch them were used only once. So space shuttles, vocab word, space shuttles are reusable spacecraft that transport people and materials to and from space. Space shuttles return to Earth and land much like airplanes. NASA's fleet of space shuttles began operating in 1981. As the shuttles got older, NASA began developing a new transportation system, Orion, to replace them. The International Space Station. The United States has its own space program, but it also worked with the space programs of other countries. I'll go ahead and change. In 1998, it joined 15 other nations to begin building the International Space Station, which is shown in the figure below. So let's take a look at that. There you go. The International Space Station is an Earth orbiting research laboratory. Astronauts from many countries have been working and living there since 2000. Research conducted aboard the International Space Station include studying fungus, plant growth, and how human body systems react to low gravity conditions. All right. So that is what we need to take a look at. Okay, so the 3 that we had were the Apollo Project, STS, and the International Space Station. So let's go ahead and go into our notebook and see what we got going on. Okay, so the Project Apollo. Okay, so it is a series of space missions designed to send people to the moon. Okay. So I've got some other information to add in there, but let's go ahead and get all three of these filled out. Okay, so the STS. So space shuttles are reusable spacecraft that transport people and materials to and from space. So space shuttles are reusable spacecraft that transport people and material to and from space. Okay, so it's reusable space shuttles. Okay, so make sure you stop and get that filled in. And our final one is the ISS. So it's an Earth orbiting research lab continually occupied by astronauts since 2000. Okay, so I'm going to go in and we're going to add a little bit to this page here. So let's use blue. So the Apollo project, so it was in 1961. It was President Kennedy challenge that we would be the first to put a man on the moon, 1961. Okay, so then in 1969, it was Apollo 11. And it is Neil Armstrong. And Buzz Aldrin. Neil Armstrong is a Boilermaker. Okay, so let's come over here to the ISS. This is several countries. So it's an international space station. So several countries. Okay, it is international. Okay. All right. So one other thing that I want to mention here on this particular page, we'll put it over here, that we first sent dogs, monkeys, and chimpanzees into space because it was unsure, the effect of weightlessness and the effect of the radiation, what that would do to a human. So, alrighty, so that takes care of that first section. And so we're going to come down to space technology. So make sure you stop this video and get this filled in if you need to. And let's go back to the reading essentials. Okay. All right. The space program needs materials that can survive the extreme temperatures and pressures of space. Many of these materials have been applied to everyday life on Earth. New materials. Space materials must protect people from extreme conditions. They also must be flexible and strong. Materials developed for spacesuits are now used to make racing suits for swimmers, lightweight firefighting gear, running shoes, and other sports clothing. Safety and health. NASA developed a strong, fibrous material to make parachute cords for spacecrafts that land on planets and moons. This material is 5 times stronger than steel. It is now being used to make radial tires for automobiles. Okay, so let's stop and bounce back up to here. So we've got some racing suits, lightweight firefighting gear, running shoes, sports. And here we have radial tires. Some medical application. Artificial limbs, infrared ear thermometers, and robotic surgery have roots in the space program. So do orthodontic braces. These braces contain a hard, strong ceramic material that was originally developed to strengthen the heat resistance of space shuttles. All right, so we've got a lot here. Braces. Remember that from our Get Ready to Read? All right, so let's scroll. I see that we have reached the end of lesson 2. So if you have not gotten this far on your vocab, you need to be getting these words done. All right? Okay, so space technology. So this is what we're going to do to answer this next section in our notebook. All right? So the space suit materials, what we used those for would be racing swimsuits, and firefighting gear, running shoes, and sporting clothes. Okay, so the parachute fiber, the one that is stronger than steel, remember what that is used for now? Radial tires. All right, so the ceramic, the hard outer shell of the space shuttles for heat resistance, what is that used for? Some of you might have those in your mouth. They are used for orthodontic braces. Some orthodontic braces. Okay. And then other technologies with medical applications. We have purple, artificial limbs. We have ear thermometers, infrared ear thermometers. And our last one, robotic surgery. Okay. So make sure you get that all filled in. So let's take a look at this, analyze it. Imagine you are a scientist planning a space mission. What factors must you consider when deciding whether to send humans or robots on the mission? All right, so what we need to think about here is that missions involving human space travelers, they're very dangerous and can only occur relatively close to Earth and for short durations of time. So that's if we're trying to think about humans. All right, so missions. Involving space travelers, let's call them that, are very hazardous. And can only occur relatively close to Earth. We can get them back, right? And for short durations. Okay, so, but what about if we want to study something that's a little bit farther out? All right, so that's where we're going to be looking at using robots. Okay, we're going to be looking at those space probes that are not designed to return to Earth, right? Okay, so robots, they can travel for years. For years and years. And can even exit the solar system and never return. So what are we wanting to look at? If it's way out there in the solar system, then we best be sending a probe. But if we're wanting to study something a little bit closer to Earth, you know, those scientists and astronauts up on the ISS stay up there for 6 months or so. Got to stay somewhat close, okay? So, exit the solar system and never return. Remember, these probes are designed never to return. So that is going to be a better deal for you, for us, if we're wanting to study something, you know, out past what we are able to study at this point safely with human missions, okay? Alrighty, so that wraps up lesson 2. Continue to work on your vocab and reach out if you need anything. Bye-bye now.